Hey everyone, welcome back. In this series so far, we have covered HTTP basic and API key authentication, which comes under pre-authentication. We also covered a couple of recipes like how to activate the user using email verification, how to reset the password. Now in this video, we will start learning JWT, which is JSON Web Token. So let's get started. Alright, so what exactly is JWT? JWT is JSON Web Token. It is a token that is exchanged over internet over web between two parties. Now this token has some information which is also called the payload, and the format of that payload is JSON. That is why it is called JSON Web Token. As you can see from the definition that this is an open standard and it is used to securely transmit information between two parties as JSON object. Additionally, this token can be digitally signed, okay, and it can be verified. Now that we understand what is JWT, let's understand when to use JWT. So there are two primary use cases. Number one, authorization. This is the primary use case of JWT, and we have heard and seen JWT being used with OAuth, for example. So we can use JWTs in the authorization. The second, of course, is the information exchange, because we have seen in the definition that it is securely transmitting some information between two parties. Now this information doesn't have to be authorization specific. Any party can send any payload to other party using JWT. So the second use case is information exchange. Alright, so we know JWT is a token that gets exchanged over internet, and we know when to use JWT, but how does this token look like? Well, if we talk about the structure, a JWT token has three parts. Number one, the header. The second part is payload, and the third part is signature. We will cover the details as we go on. So header has some metadata, payload is the actual data that is getting transferred between two parties, and signature is the part that is digitally signed, that digitally signs this token so that it can be verified. So all these three parts are separated by dot, as you can see. So this is the sample structure. We have the header, then we have the dot, then the payload, then again the dot, and then the signature in the end. And here we can see a sample JWT token, and if we just focus on the structure, then we can see this is the header part, this is the payload part, and in the end you would also see the signature part, and notice the dot. So all these parts are separated by dot. Suppose we have the JWT token, we have two parties, we have the internet connection, but how do we pass the JWT? So to use the JWT, to pass the JWT, we use the authorization header. And in this authorization header, the value always starts with the text bearer with space, and then we pass the actual token. So when one party is sending the JWT token to another party, it would use the header authorization, and the value would be bearer space the actual token. Alright, so that's how we pass JWT token from one party to another party. Alright, so let's now understand some keywords that you will often hear with JWT, and these are called token attributes. So the first one you would generally hear is the claim. Claims in a very simple sense is a set of metadata about an entity. So this is always in key value pairs. So here you can see this is the statements about the entity. This is some kind of metadata about the entity, like issuer. This simply means who created the token, who is issuing the token, subject, which is sub. Now this tells who the token is about, what is the user ID, who is the principal. Then we have something called audience, who the token is intended for. Alright, expiration, what is the expiry time of the token, because tokens can be expired. And then we also have something called refresh token. So we will cover this when we cover the token invalidation and expiration. So the idea is to generate two tokens. The first one would have lesser expiration time, that means it will expire very quickly, while the second one would be a longer lived token, which is called the refresh token, that can be used by the party to generate a new token. Alright, so we will cover these scenarios. These are some of the important key attributes that you will hear about JWT. So let's move on. Now that we understand the basic concepts, let's use this tool to understand or visualize how JWT token looks like. So you can see this is jwt.io, which is the home page of JWT. And here in this decoder, we can play with JWT. So here is a sample JWT token, and you can see it is pretty long. And as we discussed earlier, this is the header part, this is the payload, and this is the signature. And you can see these are separated by dots. So we covered this already. This is the structure of JWT token. Now this token is decoded. You can see on the right hand side. So first we have the decoded header, and the decoded header in this case can have some metadata like what is the algorithm, what is the type of this token. So we can see this is JWT and this is the algorithm HS256. And as we will see soon, there are many algorithms that we can use to sign the token. All right. Then the second part is the decoded payload. So this particular string, as you can see, encoded string represents this payload, and in this payload we have some claims, some information about the entity. So this is the subject, this is the name of the subject, and this has some custom metadata whether the admin is true or not. And in the same way we can have custom claims when we create the JWT token about a principal, about an entity. All right, so these are always in key value pairs. And for example, this is another attribute IAT. All right. And the last part, which is optional, is the signature part. So you can see this is the secret that was used to sign the token. All right. Now, if we want to expand it further, we can do that. If we go to this part, which is claims table, let me clear the screen. So you can see some more details that this is the subject, this is the name, this is the admin, basically the custom claim, and IAT is basically the time at which the JWT was issued time. And in the same way, we can expand this one also. So here we can see the algorithm is HS256, the algorithm used to sign the JWT, and the type is JWT, actually the media type of this complete JWT. All right, so you can use this tool, use this playground to better understand JWT. Then you can find more information under introduction. So you can see there is a lot of information available here for you to go through. Okay, but the gist we have covered: what is JWT, what is the structure, how does it get transferred, how do we sign the token, all these things we will also understand as we go on. All right, so what we have learned so far, that is all fine about JWT, but let's understand how do we actually use JWT in the authentication flow. Now, important thing here to understand is that JWT does not authenticate itself. It does not perform the authentication. It is just the representation of some information, some metadata that two parties understand. All right. So here we can see there are three entities: client, the server, your backend application, and the user store. What is this user store? That is first we need to understand. As I said, JWT does not authenticate itself. So that means we need to authenticate the user somewhere else. Now, as you have heard, JWT with OAuth, in that case, it is generally the OAuth which handles the authorization part. And once the user is authenticated and authorized, that identity of the authorized user is represented by a JWT token. So when we use JWT with OAuth, then that part is handled by the OAuth. But in this case, because we have not covered OAuth, so what we will do, we will adopt a similar flow as we did in the HTTP basic. So what we will do, we will register the user first and we will store the data in the database. And that will be the user store in this case. All right. And as we move on with the course, when we cover the OAuth, then we will replace this part, this user store, with OAuth. So the bottom line is we need to authenticate the user first. We need to authorize the user first, and then we will identify, or then we will represent that identity using JWT token. All right. So in this case, what would happen? We will have the client, the backend application, and the user registration part. Basically, we will have the user data in the PostgreSQL database. Now, when the user wants to access some secured resource, we know the user must authenticate first. So in this case, what will happen? The user will provide the username and password to the backend application, and then the user will be authenticated first. And in this case, because we have the data in the database, so we will write some logic to authenticate the user using username and password. If the user is authenticated, if we can match the username and password, then the server will return a JWT token. So at this stage, when the user is authenticated, the backend application will create a JWT token, and this JWT token will be returned to the client. Now, it is the responsibility of the client to store this token somewhere. It could be a cookie storage, it could be a local storage, anywhere. So the client must store this JWT token. Why? Because then in subsequent requests, the client needs to send this token using the authorization header. The value would be, as we discussed, the bearer and then the token itself. So in subsequent requests, what this client would do, instead of providing the username and password, it can simply pass this token, this JWT token, in the authorization header. Now, what server will do, it will validate the token, because as we said, this is the representation of the authenticated user. So when we create the JWT token, we will put some claims in this token that the server can decode and validate on the basis of that metadata. Alright, so we will cover these details as we go on, but the thing is, when the client passes the JWT token, the server would have enough information after decoding the token so that it can validate the token, and then it can also validate the user. And depending on the authorization and validation part, then the server would return an appropriate response back to the client. Let's say the client is trying to accessing a secured resource, then the server would allow or disallow depending on how the validation goes. In a nutshell, the first step is to get the JWT token, and then in the subsequent requests, the client can keep sending the same token until the token is expired, that we will cover next. All right. But if we just exclude the expiry, the client will keep sending the JWT token, the server will validate the token, and it will allow or disallow the client whatever it was trying to access. The important thing I'm repeating again is that the JWT does not authenticate itself. We would need an authentication mechanism where we can validate the user before generating the JWT token. Alright, let's move on. Now we will understand about the token expiry and refresh token. So in the previous scenario, when the server generated and returned a JWT token, the client was always using the same token. Okay, so because there is no expiry in that case, the token is valid forever and the client can use the same token forever. And this is not something that we want. For the security purposes, we want some control over the token. And that is where the expiry comes into the picture. So what generally happens when we generate the token and when we return the token, we set some expiry time with that token. So for example, that token could have a 15-minute expiry time. That means the token is only valid for 15 minutes. In some other cases, we can have different expiry times like 24 hours or maybe for a week or maybe for 30 days, something like this. So the token should always have an expiry time with it. All right, so now we have the expiry with the token. The token can be expired. But what happens when we use the expiry with the token? Now, when the client is accessing any endpoint, the client would provide the bearer token as always, in this case JWT token. The server would validate the token on the basis of expiry as well. If the token is expired, the server would reject the request with 401. Now you can see we have some control over the token, so the client can access a resource as long as its token is valid. But that also means since the token is expired, the request will be rejected, so client needs a new token. So in that case, the client would have to log in again to generate the new token. Now in some cases, it is totally fine. It depends on the use case as always. Say you have a token expiry of 30 days, so it is fine to ask the user to log in every 30 days. But what if the token expiry is 15 minutes? That means the client would have to log in every 15 minutes, which is bad UX. So that's where we use the concept of refresh token. So what happens in this case when the client is authenticating itself to get the JWT token at step number 1, the server not only returns the JWT token, but it also returns the refresh token. Now say your access token or the JWT token has a token expiry of 15 minutes. In this case, the refresh token could have a longer expiry time, say 7 days or 15 days. So while the JWT token is only valid for 15 minutes, the refresh token can be valid for 7 days or 15 days. Now what happens when the client is sending the JWT token in a request and say the token is expired, the request will be rejected and the server would return a 401 unauthorized response. In that case, client now has a flexibility to send another call to the server using refresh token to automatically generate the new JWT token. So as always, it also depends on the client as well and the use case what we are going to implement. But with the help of refresh token, a client can actually automate this process. So when the client is making a call to the server and say the token is expired, we know it will get a 401. Now the client can handle this request. It can make another call to the refresh endpoint with the refresh token to generate a new JWT token, and subsequently it can use the newly generated JWT token as it was doing before. So that's what we will see in this token expiry and refresh token section. So here we can see we have the client, we have the authentication endpoint, we are exposing a new endpoint which is refresh, and this represents any secured endpoint which the client wants to access. Now what would happen, this part we already know. When the client logs in, it will provide the username and password. In this case, the server would validate the username and password, and if the user is valid, it will generate and return a new access token. Now this access token is JWT, but additionally, when we are using token expiry and refresh token, we will also generate a new refresh token, and the refresh token would also be sent back to the client. Now, same as before, the client would store both the tokens in cookie or local storage, wherever it was storing. So it now has the access token and the refresh token. Now this part we also know that in subsequent request, when client is accessing the secure endpoint, it will use the authorization header and it will send the JWT token as bearer token. That is fine. Here it is able to access the secure endpoint. But suppose the token is expired. So in this request, when it was sending the JWT token, the server validates that, okay, the token is expired. And in this case, the server would return 401. Now the next step for the client is to actually use this endpoint refresh, this one, and it will be used to generate a new token using the refresh token. So what the client would do, it will actually hit this refresh endpoint and it will pass this refresh token this time. All right. So the server, what server will do, it will validate the refresh token, and if the refresh token is valid, then it will generate a new access token, a new JWT token. And additionally, what we can implement, we can also check it. Let's say if the refresh token needs to be refreshed again, because refresh token can also be expired. So these kind of things we can implement in this flow. Now the client has the new JWT token. So in the subsequent request, it can always use the same token as it was doing before. By same token, I mean the same flow, because we now have the new token. All right. So that is how we use the JWT tokens and the refresh tokens to basically handle the token expiry part. Now there is another scenario. Say, what if the refresh token is also expired? So in this flow, when the client was trying to generate new JWT token using refresh token, what if this refresh token is also expired? So as always, there are a couple of ways to implement this depending on the scenario. So what we can do, if the refresh token is invalid, is expired, so we can simply reject the request and we can ask the client to log in again. That means using this auth endpoint to generate the new token that would also generate the new refresh token. Or we can also refresh the token in the same call on the backend. So we can, that is why it says potentially. So we can potentially refresh the token as well. We can generate a new refresh token. We can generate the new JWT token in the same call, and then we can return the newly generated JWT and newly refreshed refresh token. So these are just the concepts, and the implementation depends on the use case, what kind of client we are trying to implement, what kind of server we have. So now that we have covered the basic concepts related to JWT and we are aware of the fundamentals of JWT, we will move on with the hands-on demo.